Imagine a world where machines not only automate tasks, but think, learn, and reason like humans across any field. That's the promise of artificial general intelligence, or AGI. Unlike today's AI, which is narrow and task-specific, AGI aims to match or even surpass human intelligence in every domain. But how close are we to building such a powerful system? Is it decades away or just around the corner? Let's explore the science, breakthroughs, and challenges behind humanity's race toward true machine intelligence. Today we will talk about what is AGI and how close are we to it. So before we start, make sure to hit the like button and subscribe to my channel. The evolution of AI, from rule-based systems to learning machines. To understand AGI, we must look at the historical progression of AI itself. Early AI systems in the 1950s and 60s relied on hard-coded rules created by humans. These rule-based systems could perform logical operations but were brittle and unable to deal with the real-world complexity. The 1980s saw a shift toward expert systems, which encoded human expert knowledge into computers, but they too were limited in adaptability. The major breakthrough came in the 2000s with the rise of machine learning, particularly deep learning in the 2010s, where neural networks began outperforming humans in specific tasks like image recognition and language translation. These developments gave rise to powerful AI models like GPT, DAL*E, AlphaFold, and AlphaZero. However, despite these impressive accomplishments, these models remain narrow in their focus. They excel at individual tasks, but lack the adaptability and reasoning power of a general intelligence. Core capabilities of AGI. AGI is not just a faster or larger version of current AI systems. To qualify as general intelligence, an AGI must exhibit several core competencies: learning from limited data, understanding and generating human-like language, reasoning through abstract or novel situations, applying knowledge across multiple domains, maintaining long-term memory, making ethical decisions, and adapting to unpredictable environments. AGI should also have a sense of self-awareness, or at the very least, situational awareness, that allows it to comprehend its role in a context and adjust accordingly. In practice, this would mean that an AGI could solve a math problem, write a philosophical essay, diagnose a disease, learn a new language, manage a business, and even form interpersonal relationships without requiring separate programming for each task. AGI vs. human intelligence, the comparison. The dream of AGI lies in its ability to replicate or surpass human intelligence. However, human intelligence is not just logical. It is emotional, intuitive, and deeply social. We possess common sense, empathy, and the ability to learn continuously from experience. While machines today can process data far faster than humans, they still struggle with real-world context, ethical nuance, and creativity that isn't based on patterns in training data. AGI aims to bridge that gap. The ultimate test of AGI would be the Turing test, but more advanced frameworks like the coffee test. Can the AGI enter a house and make coffee using available tools? Or the embodied AGI test. Can it interact physically in the world like a human, offer even more realistic measures? True AGI should pass these challenges with competence comparable to humans. The technological challenges in building AGI. Creating AGI is not merely a matter of building larger neural networks. The path involves fundamental breakthroughs in multiple areas. One major challenge is learning efficiency. Humans can learn complex tasks from just a few examples, while AI requires enormous data sets. Transfer learning, causal reasoning, meta-learning, and symbolic reasoning are some of the core research domains being explored to solve this. Another hurdle is building memory systems that work like human long-term and working memory, allowing AGI to remember and recall facts, experiences, and strategies. Autonomy and self-supervision are also critical. AGI must learn without always being told what to learn or how. Moreover, combining symbolic AI, logic-based reasoning, with deep learning, pattern-based learning, is seen as a potential solution, creating hybrid models that combine the best of both approaches. The ethics and risks of AGI. The prospect of AGI brings with it not just excitement but serious ethical concerns. An AGI system, if misaligned with human values, can make decisions that have catastrophic consequences. Imagine a superintelligent AGI optimizing for efficiency without regard for human well-being. It could disrupt economies, override human commands, or even pose existential threats. Experts like Nick Bostrom and organizations like the Future of Life Institute warn that the first AGI might be the last invention humanity ever makes unless we get alignment and safety right. Questions of control, consciousness, accountability, and moral status become urgent. Should AGI have rights? Who is responsible for its actions? And how do we ensure AGI remains beneficial to all, not just a few powerful entities? These aren't just philosophical questions. They're immediate design requirements for AGI developers. Leading AGI research labs and projects. Several organizations are working directly or indirectly on AGI. OpenAI, originally founded with the explicit mission to build safe AGI, has released models like GPT-4 and GPT-4o that approach general capabilities in language and reasoning. DeepMind, a subsidiary of Google, has developed AlphaGo, AlphaZero, and most notably Gato, a single model capable of playing games, chatting, and even controlling a robot. Gato is considered a step toward generalization. Anthropic, co-founded by former OpenAI researchers, is focused on building aligned, steerable AI systems. Mosaic ML, Inflection AI, Conjecture, and XAI, Elon Musk's new AI company, are also pursuing AGI from different angles. Meanwhile, academic institutions like MIT, Stanford, and UC Berkeley continue pushing foundational research in neuroscience-inspired AI, robotics, and reasoning systems. How close are we really to AGI? This is the billion-dollar question. Opinions vary wildly. Optimists like Ray Kurzweil believe AGI could emerge as soon as 2030, arguing that exponential growth in computing power, data, and model capabilities will converge within the decade. Others, like cognitive scientist Gary Marcus, believe we are still decades away, citing that current models lack true understanding, reasoning, and generalization. The launch of frontier models like GPT-4o and Claude 3 has impressed the world, but they still show clear limitations in memory, abstraction, and real-world grounding. While they simulate intelligence remarkably well, they often hallucinate facts and struggle with long-term coherence. So while we may be seeing glimpses of pre-AGI, most experts agree that true AGI remains a work in progress. Perhaps within 10 to 20 years, if breakthroughs continue steadily. AGI in the real world. Potential impacts. The arrival of AGI would transform every aspect of human life. In education, AGI tutors could personalize learning at an unprecedented scale. In healthcare, AGI doctors could diagnose, monitor, and treat patients with precision. In science, AGI researchers could accelerate discoveries in quantum physics, biology, and medicine. Economically, AGI could automate most white-collar jobs, raising both fears of unemployment and hopes of post-scarcity economies. Politically, nations may race to develop AGI, leading to new kinds of power struggles, regulations, and international treaties. Socially, AGI could reshape our understanding of consciousness, relationships, and even spirituality. However, without inclusive governance and alignment, the benefits of AGI might be monopolized, exacerbating inequality, surveillance, and control. If you like this video and would like to see more like it, please give it the thumbs up, leave a comment, and click the button to subscribe.